you had a great long weekend. A couple reminders before we get started with 10.25 for today. You do have a homework quiz on Tuesdays. So tomorrow, Tuesday, 10.25, like I said in class last week, this will not be on the homework quiz. However, we're going to cover some important information today. So we will be going over the homework for both 11.2 from last week, as well as your homework for tonight, which is review preview 10.25, problems 81 to 86, not 87. You do not have to do 87. All right, and last reminder is you have your test at the end of this week. So this homework is actually going to be a great review for what we went over in chapter 10. All right, so let's get started. So like I said, we're doing 10.25. Today we're going to figure out the quadratic formula and where it came from. So we're going to derive that, and we are going to learn about a new kind of number today, just to touch on it. I think it's some useful information. So starting with the quadratic formula, we're going to figure out where this comes from today, all right? So our problem right now is to solve ax squared plus bx plus c equals 0, or standard form quadratic. And we're going to do that by completing the square. So if you remember, the first step in completing the square is we need our leading coefficient for this to be 1. It is most easily done when the a term is 1. All right. So we are going to, first off, I'm going to scooch this c over because we're going to have it on the other side anyway later on. So I'm just going to get it out of the way now. And if you remember the quadratic formula, we are solving for x, right? It's x equals, if you remember the song, negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is our goal for this, all right? So first things first, I am going to scooch that c on over. So I'm going to have ax squared plus bx equals a negative c. And I want to get, remember, our leading coefficient should be 1. So I'm going to divide all of this by a. So we should be left with x squared plus b over a x equals a negative c over a. Now, if you remember with completing the square, there were two ways that we talked about doing this. I'm going to talk about both of them right now. So we are going to make our square, my very ugly square. And remember, we have our x squared that goes in this bottom left-hand corner. And if you remember these two squares right here, it is the b term cut in half between these two squares, right? Because they have to add to that middle term. So it would be 1/2 times b over ax in both of these boxes. All right. And remember, we want to find, when we complete the square, we want to find this box. So our two binomials, our perfect square would be x and a 1/2 b over a, which actually just simplifies to, I'll put it right up here, b over 2a, right? So that would be the start of completing the square. And when you multiply those two together, you are going to get, let's see, if you do 1/2 b over 2a, or sorry, b over 2a squared, we should get b squared over 4a squared in this box right here, all right? So with that being said, when we complete the square, you should have x plus b over 2a quantity squared minus our b squared over 4a squared equals our negative c over a. All right. And now we want to get our x value alone, because remember, our goal is to solve for x, right? So our next step would be to move this guy over. We're going to add this value to both sides. So we are left with our x plus b over 2a quantity squared equals positive b squared over 4a squared equals minus C over A. All right, and I want to add these together, right? I want to combine as many like terms as possible. So in order to add our b squared over 4a squared minus c over a, what do we have to do? When we're subtracting fractions, we need a common denominator, right? Fraction busters. So I'm going to multiply this guy, this negative c over a, by 4a over 4a. Now, why did I do that? Because we have our 4a squared in this denominator over here. So that would give us, in our denominator for the negative c over a, the 4a squared. All right. And once we simplify that, let's see, this works out to be, if you do b squared over 4a squared minus, when you distribute that in, it's 4ac over 4a squared. That'll leave you with, on this side, b squared over, if you do both, it's b squared over 4a squared minus 4a over 4a squared. When you simplify that, you're going to have b squared minus 4ac all over 4a squared, right? And that would equal your x plus b over 2a quantity squared. All right. And our next step now, we have this square root, or we have this squared quantity on our one side. And when we are solving for x, we want to now we want to take the square root, right? We want to get rid of this square value. So I'm going to take the square root of both sides, and you should be left with the absolute value of x plus b over 2a equals, and when you take the square root of this whole right side, first let's start with the numerator. We have b squared minus 4ac all over, when you take the square root of 4a squared, you're left with 2a. All right, and we are almost getting there. What do we do when we take the absolute value of one side? That gives you our two equations, the plus something and minus something, remember? So we are going to be left with x plus b over 2a equals plus or minus square root of b squared minus 4ac all over 2a. And we are almost there, as you can tell. And our last step would be, or almost last step, sorry, x, we're going to move this b over 2a. We want to subtract it. Move it to this side. We're going to subtract it. All right. So we have x equals our negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And we have our common denominators here. So when we simplify or combine those, your ending should be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's exactly what we wanted. All right, so that is how we get the quadratic formula. All right, moving on. I want you guys to try these. Pause the video here if you remember what we did in class last week involving the discriminant. Pause the video here. You do not have to solve all of these, but find how many solutions each one of these has. All right, so pause the video here. All right, did you give these a try? Let's start with A. So your discriminant for A, and if you remember the discriminant is what is inside the radical of the problem. So it is the b squared minus 4ac. All right, so for problem A, hopefully this is a nice review for you guys. So problem A, the discriminant should have been 14 squared minus 4 times 8 times a negative 15. And you'll see you end up with a positive discriminant here, so that'll give us 2 solutions. All right. B, the discriminant should have been, let's see. It should have been 8 squared minus 4 times 1/2 is 5/10 times 3. And you'll see again, this one is another positive, so we have 2 solutions here. For C, the discriminant should have been -10 squared, quantity squared, and that is inside the parentheses, remember, plus -10 quantity squared minus 4 times 1 times 30. And that should have been a negative value, and so that means no real solutions. And we'll talk about that in a second. No real solutions there. And the last one, your discriminant should have been -4 quantity squared minus 4 times 4 times 1. And this comes out to be 0. And if you remember, when our discriminant is 0, you have 1 solution. All right, hopefully that was a nice review for you guys. The last thing we are going to do today is let's talk about imaginary numbers for a bit. A lot of you have been asking, what happens when there is a negative under the radical? Well, if you plug in, and actually pause the video right here, plug this equation, this quadratic, into your Desmos graphing. Pause the video here. All right, and hopefully you had the chance to do that. And you would see there is nothing on that graph. When you plug in 0 equals x squared plus 1, there is nothing that appears to be on that graph. So let's solve it. Let's see what happened there. So when we solve 0 equals x squared plus 1, and if you remember our shortcuts that we learned earlier when learning about solving quadratics, this is a no real solution. Why? It is not a perfect square. It's not factorable. You can't find it, all right? So, but when we solve it, I'm going to subtract 1 from both sides. So you have a -1 equals x squared. And now I'm going to take the square root of both sides. And this is what we are left with. And the square root of -1 is what I'm going to begin to talk about as an imaginary number, all right? So an imaginary number, and bear with me really quick, by the 1500s, people trying to solve equations like the ones that we just did not have real solutions. So they came up with this thing called imaginary numbers. And imaginary numbers were very reluctantly accepted. I could see why. This is a bit, out there of an idea. But the square root of -1 is now noted as this little I. Ooh, tripping over this candy over here. As this little I, all right? And we're going to use that, not necessarily now, but I think this is an important concept, especially when you get to high school. Something very cool. So if you have not already done so, we found the solutions for this guy in the original problem we just did. We are going to solve this guy right now using our idea of imaginary numbers. All right, so pause the video here and give this one a try. All right, hopefully you got a chance to do that. And we are given x squared plus 81 equals 0. So I'm going to move that 81 over to the other side, and you have x squared equals a -81. And we'll take the square root of both sides. And our solution is going to be x equals a plus or minus the square root of -9, right? And I'm sorry, I actually did not touch on that in this last equation. You should have gotten 2 solutions for this one, right? Plus or minus. But in this case, what can we pull out of here? Well, if you remember 9 is a square number, then, this should be an 81. If you remember 81, is a square number, you should be able to pull a 9 out of here. So you are going to have a 9 plus or minus the square root of -1 left over. All right, and I'm just going to leave it like this because, and we'll learn more about the I notation, the imaginary notation, when you have the chance in high school for a bit, but this is how you would write this problem. This is how you would simplify this Radican. All right. This is the last thing we're doing right now. So if you have any questions, again, feel free to comment or shoot me an email. Otherwise, again, your homework quiz is tomorrow on Tuesday, and your test will be at the end of this week. So your homework for 10-5 will be a great review for that. All right. Have a great rest of your weekend, guys.